Hello guys, today we're going to study 3.5 rational functions and their graphs. Rational functions are quotients of polynomial functions. So we can write it as f of x equal to p of x over q of x. So example 1, finding the domain of a rational function. So for part A, anytime you have a question like this, all you have to do is we're just going to set the denominator cannot be equal to 0. So the denominator in this case is x minus 3 cannot be 0. Then we're going to solve it at 3 both sides. You're going to have x cannot be 3. So we cannot have x equal to 3. Let's going to just go back to the basic really quick. So if here we have a number line, let's say this is 0 and then this is 3. So we have to get rid of this. That will be an empty circle. And then everything else will work. Let's go ahead and write it in the notation form. So the domain, that will be, we look at this graph from the left to the right, that will be from the negative infinity to 3. We also have from 3, from here to the positive infinity. Let's look at B, exactly same thing. So what we're going to do is we're going to set the denominator cannot be 0. Then we're going to solve it. We're going to have x squared cannot be 9. And then we're going to take a square root of both sides. Then we have to remember cannot be equal to positive negative square root of 9. We're just going to have x cannot be positive negative 3. So again, you can draw this on a number line. So this is one empty circle, negative 3. We also have to get rid of positive 3 as well. Everything else, that will be here. Okay, so we're basically paused at negative 3 and then add the positive 3, then everything else that work. So you write your notation form. Our domain for this question, that will be, we're going to start with negative infinity to the negative 3. We're also going to have negative 3, right? From negative 3, this distance right here, to 3. And then we'll also have to have from the positive 3 to the positive infinity. That is our part B. So for our part C, so if I solve this, I'm going to have x squared cannot be negative 9. If you look at this, x squared cannot be negative 9. You have to realize any real number, if I'm going to square it, they'll always give us a positive number. Okay? Which means in this case, every single real number that would work. The domain from negative infinity to positive infinity. Before we start example 2, let's take a look at the reciprocal function. F of x equal to 1 over x is the most basic rational function. Okay, let's take a look at how this graph look like. So let's make a table really quick. So you have done this before. If I want to label it for 0, because we know x cannot be 0, so that will be undefined. So if I plug in 1 over 4, so you're going to get 4. So on, you plug in everything. Okay, so you've done this before so many times. If you plug in all those points, you could get graph or something like this. So you just, for example, from your 4, this pair 4 1/4, you just plug in right here 4 1/4. Okay, like this point, for example, that is 4 1/4. So you're just doing the same thing for every single point. Eventually, you're going to have a graph like this. You will have some homework questions. Let's look at the graph. You have a question like this. They give you a graph. When we have symbol like this is how you read it. As x approaches 0 from the left, when you have a little minus sign right here, that means approaches 0 from the left, then f of x approaches what? So from this graph, alright, so we know this is 0, right? So we're going to say as x, you're looking x right here, left to right, as x approaches to 0, okay, we get, basically means it get closer to 0. Your x will get closer, here it's getting closer, and get even closer, like to 0, right? What happened to your function? Red line, that is your f of x. So as your, again, let's look, as your x get closer to 0, then you realize your f of x is getting to where? Going down forever. That means the negative infinity. That is how you look. So let's take a look for part B. For this graph, as x approaches 0 from the, so that means from the right side, so here we have a 0. So approaches 0 from the right, so that means we're getting this, getting closer to 0, getting closer to 0, getting closer to 0, and then what happens to your graph? Your graph is going to go up, up, up forever. That means f of x approaches to positive infinity. Okay, let's take a look at how to do part C. We have a homework question like this. As x approaches 4 from the left side. So here we have a 4 right here. That's my 4. And the left side for this 4, that will be this side, correct? So as x get closer to 4 from the left side, then we're going to take a look at our graph. That is our graph, our blue color. That means our graph goes down, down, down. So that means our f of x approaches to negative infinity. So let's take a look at another one. So as x approaches to 4 from the right side, x, let's say approach it from the right side, that's the right side. Then you look at your graph, only the graph right here is working, right? So this graph actually goes up, 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 up to the positive infinity. Let's go ahead and take a look at another one. As x approaches negative 3 from the left side, the negative 3 is right here. That's my negative 3, okay? From the left side, which means I'm going to go from the left side, okay? And then we look at our graph. So our graph is going up, up, up. That means f of x approaches positive infinity. You can pause the video to go ahead and practice on your own, okay? As x approaches negative 3 from the right side, so that means we're going to get something like this, alright? Get closer, closer. And then we realize your graph going down, down, down. That will be f of x. It approaches negative infinity. So the last one's really, really tricky. So as x approaches negative infinity, not a specific number. So we look. So x get closer to negative infinity, that will be our x go this side forever, right? So then what happens to our graph? Let's just imagine this extended. Because here we have a line right here, alright, blocking us, we cannot cross over. We're only going to get closer to 1. So that is how you look at this type of question. So here we have the definition of vertical asymptotes, and then you can pause the video to take a look at them. So how to locating vertical asymptotes. Okay, let's take a look at the example 2. Then we know how to use this. So we're going to start with, so fx equal to, so x over, so here we can factor this as x plus 3 and x minus 3 form. Then we're going to check, can we factor anything? And then we say no. Alright, then we say there's no common factor. So we're going to solve the denominator. So we'll set it to 0, which will give us x equal negative 3 or x equal to positive 3. So which means those two numbers are 0 of the denominator. Therefore, x equals negative 3 and x equals 3 are vertical asymptotes. So it's really simple. You factor it first. Okay, and see if you can cancel anything. If there's no common factor, then we set denominator to 0. We're going to solve it. Then once you find the zeros, there are also your vertical asymptotes. Okay, if you use a graphing calculator, so you're going to have something like this, which confirm we're right. So this will have a vertical asymptote right here, x equal to negative 3. And then we have the vertical asymptote, x equals 3. Okay, so let's look at part B. So in this case, we're going to factor first. We'll factor denominator because that's the only one we can factor. We're going to have x plus 3 and x minus 3. So once we have here, what we want to do is we're going to see if we can cancel anything out. So in this case, we can cancel x plus 3 out. So what you're going to have left is 1 over x minus 3. So once we have no common factor, so we're going to set denominator to 0. So we're going to solve it. You're going to have x equals 3, which means that x equals 3 is the vertical asymptote. So you're going to question what happened right here. Okay, let's go ahead and let's take a look at the graph. So if you look at here, our vertical asymptote is correct, right? That's the way to find it. And then you look right there, x equal to -3, which is this one we have canceled, right? So the one we have canceled, let me just go ahead and draw, use different color. We have canceled. If we set it to 0, we would have x equal to -3. So that is actually right here, okay? That we called it, that is a hole in the graph. Is in calculus class, we're going to say removable. Okay, anytime you can cancel, you have a hole in your graph. So part C, we have h of x equal to x plus 3 over x squared plus 9. So again, we're doing the same thing. If we could factor, we would, but if you look, it's x squared plus 9. Okay, that is not the form x squared minus b squared. So we cannot factor this. Okay, so that means we're just going to set it to 0, the denominator is 0, and then we're going to have x squared equal to -9, because this is always going to give you a positive number, and never going to exist in this case. There are no real zeros of the denominator, therefore there's no vertical asymptote. Our graph also confirms that is the case. There's no vertical asymptotes. Now let's take a look at what is the horizontal asymptote. Please feel free to pause the video to take a look at these formal definitions. So let's go ahead and focus on how to find the horizontal asymptote. So we have a rational function. We're going to say the degree of the numerator is n, right there. And here we have the degree of the denominator. And then we look at each case. Again, pause the video if you need to. So let's take a look at the example. So example 3. If you look right here, part A, we're going to have what is our n, what is our m. We have n equals 1, m equals 2. That implies our n is less than our m, which means y equals 0 is the horizontal asymptote. Okay, let's look at B. G of x equal to 4x squared over 2x squared plus 1. So in this case, we're just going to write n equals 2, right there, n equals 2, and m also is equal to 2. That means our n is the same as our m. So when we have n equals m, y equal to a sub n over b sub m. Okay, in this case, you look at the leading coefficients here. For the numerator, that will be 4, and then for the denominator, that will be 2, which give us 2. That means y equals to 2 is the horizontal asymptote. I'm just write HA. Okay, so then you look at part C. So I'm not going to copy this question this time. So part C, you look again, your m. Part C, you look again, your n is 3, your m is 2. So your n is greater than m. Right here the rule. So in this case, there's no horizontal asymptote. So that's the 3 rules. They're really important. Okay, so make sure you remember this. And then we have if m is equals to n, and then we have if n is greater than m, and then there's no asymptote. Okay, so make sure to remember those. So that is the lesson for the first part for 3.5. So we're going to continue this next time. Thank you for watching the video. I'll see you guys next time.